Okay, so this is probably, I would say, the most important lesson you can take out of the unit circle. Everything that we've been talking about has been angles and such, but this unit circle, I'm going to actually have two videos. So this video is going to focus on special right triangles. And I'm going to show you how to calculate and label everything that we need for special right triangles using this method. And then I'm going to show you another way that's pretty gimmicky, but if you are not a good memorizer, it's something that works really well. So we have this first triangle, and it says label all of our important angles here in degrees. So we know the easy ones: 0, 90, 180, 270, and I come back and hit 360. Okay, now if I have a special right triangle, I have two special right triangles. So I have a 30, 60, 90 triangle, and I have a 45, 45, 90 triangle. And those two things are super important because these are the angles that we've been talking about this entire unit: 30, 60, and 45. Those are the angles that we care about. So if I look at this special triangle, I know that if I cut my quadrants in half, so that's this purple angle here that I'm cutting in half, then this is going to be 45 degrees. And if I take 90 plus 45, so if this distance is 45 and 45 and 45, and I know we've done this before, but that makes this angle 135 degrees. Okay, another 45, another 45, I get down here to 225 degrees, down to 270, and I go over here and I hit 315 degrees. Now, again, I know I've talked about this once before, but I'm going to review it again. You see that all of our 45s, and I'm just going to write this because we're going to come back to it in a minute, pi over 4 is my 45-degree angle, and all of these end with a 5. Okay, now what else do we know about our special right triangle? We know that a 45-45 triangle is, actually, let me come back to side ratios. Let me come back to that so that I can just finish up this unit circle. So this first distance that I have right here, that's this, I'm going to just label this as blue, right? We know that this is 30 degrees. So that means that this distance right here is 30 degrees, and this distance is 30 degrees, and this distance is 30 degrees. All the way around my triangle, I have these 30 degrees distances. So if this is 30, to go from this point to get to this point, I have two of them, right? 1, 2. So this becomes 60 degrees. All right? So here I add, so from the 60, I add 30 to get 90. 90, I add 30 and I get 120. 120, I add 30, I get 150. I add 30, 80. This becomes 210, 240, 270 plus 30 is 300. This is 330, and then 330 plus 30 is 360. So super easy to do my degrees all the way around my triangle. So what you need to know is that we're going, all of these little divisions all the way around here are 30, and if we split them in half, then we've got that by 45. Okay, so now because we know that we are focused in this class on radians, we're going to do the same thing down here. And again, I've done this before, but we start at 0. We know that this is pi over 2. We know this is 1 pi. We know this is 1.5 pi. So 1.5 pi is the same as 3 pi over 2. And then all the way around, I get to 2 pi. Okay, now I'm going to go ahead and divide this guy right here just so that it's symmetric to the top one. And I know that my value here, halfway between pi over 2, so I've done this, but let me redo it. Half of pi over 2 is pi over 4. So this value here becomes pi over 4. It's halfway in between. So this becomes 3 pi over 4. Right? This one would be 5 pi over 4. And I get over here, and this one's going to be 7 pi over 4. Now, if you remember, another way to think about this is if this is pi, and my denominator is 4 in all of these cases, this is the same as 4 pi over 4. So if I want one that's less, it's 3. If I want one that's more, it's going to be 5. Well, here if I started at 0, if I go one more, it's pi. Or if I have 2 pi, 2 pi here is the same as 8 pi over 4. And if I go one less, it's 7 pi over 4. So you can think of this as two ways. You can think of it as I'm adding pi over 4, 3 pi's over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces, 7 pi over 4, 8 pi over 4. So that's how I go all the way around my unit circle. Now, it's going to be the same thing with my 30 degrees. So if this right here is my 30 degrees, I know that 30 degrees is pi over 6. So that's the value that I have here is pi over 6. So again, this was pi over 6. This is going to be 2 pi over 6, right? So if I have 2 pi over 6, then this just reduces to pi over 3. So this value right here would be pi over 3. So I have 1, 2, 3 pi over 3. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. So 4 pi over 6, and 4 pi over 6 simplifies to 2 pi over 3. So that's this one, 2 pi over 3. Now remember, what I started to mess up on here is these are all pi over 6s, right? So I have 1, 2, 3, 4. This next one over here is 5 pi over 6. It doesn't reduce. And then 6 pi over 6. This next one is 7 pi over 6. This next one is going to be 8 pi over 6, which reduces. So I would have 4 pi over 3. 9 pi over 6. If I keep going here, I would have 10 pi over 6. So this next one is going to reduce to 5 pi over 3. And then the last one is 11 pi over 6. Now, remember the cheat on this is if I know that this denominator here is 6 and I have 6 pi over 6, this gives me 1 pi, right? So 1 less is 5, 1 more is 7. Or if I have 3 pi over 3, 1 less is 2, 1 more is 4. So this is just a quick shortcut if you need to, if you're struggling with the math of adding these fractions all the way around, that's just a quick way to look at it. And then over here again, it's the opposite. 12 pi over 6 is the same as 2 pi, so 1 less is 11. And if my denominator was 3, I would have 6 pi over 3, so 1 less would be 5. Okay? All right, so now let's get into the meat of this, because this is hard to see, so let me grab another piece of paper. What this says is sketch the reference angle for each given value of theta. And then what I want to do here is I want to evaluate each trig function. Oh, sorry about that. So sketch the reference triangle for each angle and then evaluate each trig function. So the first thing that I have is 30 degrees. So this is my reference angle for 30 degrees. And what I know, if this is 30 degrees, that I can create this reference triangle by dropping this horizontal. So this makes my right angle. So if I go back to what I started over here with my special right triangles, I know that my side ratios on a special right triangle are 1, 2, square root of 3. So 1, 2, square root of 3. Now, the square root of 3 always goes with the 60. The 2 is the biggest angle, the biggest side length, because square root of 3 is less than 2, so it goes with our 90 degrees. So our special right triangle of 30, 60, 90 has the side lengths of 1, square root 3, 2. So if I go back to my reference triangle right here, if this is 30 degrees, then my side ratio opposite of that is 1. And if this is 90 degrees, then my side ratio is 2, which makes this angle up here 60 degrees. And so my 60 degree side ratio would be the square root of 3. So this is my side ratios based on known geometry special right triangles. So if I want to know What is sine of 30 degrees? Well, if I think back of what I know about sine is going to be your y angle, and we did this in our lesson the other day. So sine is going to be y over our hypotenuse or our radius. So the y value is 1, so sine becomes 1, and my r value here is 2. If I want a cosine of 30 degrees, well, cosine is the x value over r, so the x value is the square root of 3 over 2. And tangent of 30 degrees is going to be y over x, and that's 1 over the square root of 3. 1 over the square root of 3. Okay, so what you have in your binder, hold on, let me grab mine real quick because we're going to fill this out as we go. You have this table that looks like this. And so what we've just done here is we have created all of these degrees and the corresponding radians on our on this unit circle. Okay, so I can go over here and I can say that a degree of zero has a radian of 0. That value doesn't change. Okay, and I know that a degree of 30, that's this first line right here, corresponds to pi over 6. So this would be pi over 6, and then pi over 4, and I can literally go all the way around my unit circle. Now this, I'm going to draw a line right here, because this designates quadrant 1. Okay, now if I look at my reference angles for this, my reference angle, remember, because I'm in quadrant 1, my reference angle is my closest angle to the x-axis. So in this first quadrant, it's just the angles. So it's going to be 0, 30, 45, 60, and 90. So these reference angles are my angles that are closest to my x-axis. Okay. Now if we go back to what we just did here with sine, we said that sine of 30 is going to be 1/2. And cosine of 30 is going to be the square root of 3 over 2. And tangent of 30 is going to be 1 over the square root of 3. So all I did is I took these values of 30, because this is my special triangle, 30, and I wrote these angles down here. Okay? Let's go down here and do this 60-degree triangle, and we're going to come back. Okay? So 60, I know that happens right here. So if I want to find my right triangle, I drop the horizontal or I drop the vertical. So this is my reference angle of 60 degrees. And again, if I go back to my special triangles, 60 corresponds to square root of 3. So this value this time is the square root of 3. 90 stays the same. This is still 2. And this x value here is still 1. So now I want to evaluate this. So if I have sine of 60 degrees, sine of 60 degrees is y over r. So this one becomes the square root of 3 over 2. Cosine of 30 degrees is the x-axis, so 1 over 2. And tangent of 30 degrees is going to be square root of 3 over 1. Okay, so now I can go back to my table here, and I want to fill out, oh shoot, I see what I did. I made a mistake here. This should be 60 degrees, and this should be 60 degrees. So we're doing a triangle that's a reference angle of 60 degrees. So now if I want to fill these out on my table, I would have my sine value is the square root of 3 over 2, and my cosine value is 1/2, and my tangent value is just the square root of 3, because anything over 1 is just that value. So hopefully what you notice is that if I look at my reference angle of 30 and I look at my reference angle of 60, I have all the same values, 1, 2, square root of 3. All of these values are the same. All right? So now let's look at 45. So if I look at my triangle that's 45, this is going to be just a little tiny bit different. So what I know, let me go ahead and draw this in here. I know that this is my 45-degree angle. So if this is 45 degrees, this is my reference angle. Then what I have in a 45-degree triangle is I have 1, 1, square root of 2. These are my side lengths. So 45 is 1, 1, square root of 2. So on a 45-degree triangle, so if this is 45 degrees, I would have 1, 1, square root of 2. So the square root of 2 falls across from my right angle. Okay, so let me write this down. So this is 1, this is side 1, and this is the side square root of 2. Now, this one, there's a reason why this one is a little bit different. So if I want to look at sine of 45 degrees, I know that that is y over r. So we would say 1 over the square root of 2. Now, usually in trig and in calculus, we're not going to reduce and rationalize the denominator, but with evaluating these trig functions, we are. So if I multiply the top and the bottom by the square root of 2, that rationalizes the denominator, and what we get is the square root of 2 over 2. And this is how we want to report it. These two things are the same. So to get this 2 out of the denominator, I multiply by the square root of 2. So cosine of 45 degrees is, guess what? It's the same thing because this value of 1 and this value of the 1 are the same. So this is the square root of 2 over 2. And tangent here is going to be 1 over 1. So tangent of 45 degrees is just 1. So I'm going to come back here to my chart. And what I know is that this value is the square root of 2 over 2, the square root of 2 over 2, and the value of just 1. All right? So let's keep going here. I'm going to go through just this first quadrant. So here I have this angle of 0. So this angle of 0 is just the straight line. Okay? So I don't have a reference angle, I don't have anything. So if I have this kind of like a little imaginary line right here, then what I know about this is that this length on my x-axis is going to be 1, and that makes this radius 1, but this value of height is 0. I don't have any height because technically my reference angle here is 0 degrees. So this says I have, what this says right here is I have no rotation. And if I have no rotation, then I don't have an angle. I don't have anything there. So if I look at this, I have sine of 0 degrees, which is 0 over 1. So 0 over 1 is 0. And I have cosine of 0, I'm doing theta, cosine of 0 degrees. And that's this angle, which is 1 over 1. And I have tangent of 0 degrees. And if I have tangent of 0 degrees, then that ratio is going to be y over x. My y value is 0 and my x value is 1. So this value here is also 0. All right, so if I go back now to my table, what I have here is that sine is 0, cosine is 1, and tangent is 0. Okay, one more to fill in this quadrant, and then we're going to do something a little bit different. So now what I have is this 90 degrees. And so if I have this 90 degrees, I know that that's this. And this is my right angle that happens right here. And so if this is my right angle, what I have is I need to think about my distances. So this value here is 1, and this value here is 1. And so how do I create a triangle here? Well, I create a triangle by looking at, if I want to make a 90-degree triangle or an 87-degree triangle. Oh, sorry about that. Okay, so we're on this 90 degree, and what you see is that we have 1 and we have 1, but we have a problem. Because the way this angle is, I cannot draw a vertical line to make a right triangle. I can draw this and make the hypotenuse, but that's not what I want to do. I want to drop a vertical line. So if this is 90 degrees, I'm going to do something here where I'm going to say, all right, we're not going to use 90 degrees. I'm going to get infinitely close, so super close. So it's going to be a lot like this one with 0 degrees, and I drop this vertical line. So now what I know, this is my right angle. I know that this value here becomes 1, and my hypotenuse becomes 1, and then technically this distance here becomes 0. Now, I know that this is very theoretical on here, but stick with me because you're going to see kind of how this works. So now what I have is I have sine of 90 degrees. And if this is my 90 degrees, what I have here is that the sine of that is going to be opposite, so 1 over 1, which is 1. And if I have cosine of 90 degrees, well, this x distance right here is going to be 0. And if I have tangent of 90 degrees, look what I have. I have 1 over 0. And what do we know about 1 over 0? We know that this is undefined. It doesn't work. So if I go back to my little chart here, we fill out this last row, and what I have is that sine is 1, cosine is 0, and tangent is undefined. Okay, so this is what I have in my first quadrant. Now, I could go through and I could figure this out for all of the quadrants, but really what I want to do, I'm going to look at two important things here. The first thing is I am going to look at my reference angles. So I already created all of my angles, and I can go around my chart and I can fill that in. So I would have 2 pi over 3, and then 3 pi over 4, 5 pi over 6, and then pi. And these numbers are just these values from the second quadrant. Okay, so what I know is that this becomes my quadrant 2. All right, so if I go one more step, I know that my next value here, if I keep going, I have 7 pi over 6, 5 pi over 4, 4 pi over 3, and then 270 is 3 pi over 2. And these values right here become my third quadrant. And then I have, just to stay with this color theme, I have my fourth quadrant right here. And so as I go through this fourth quadrant, I keep going. I have 5 pi over 3, all the way back to 360, which I know is 2 pi. Okay, and this is my fourth quadrant. Now, here's what's important. This is super important, and you can see a pattern here. So if I have pi over 3 in my first quadrant, my denominator is 3. Well, if I see my denominator of 3 in my second quadrant, I'm going to have the same reference angle. My second reference angle is going to be 60. So if I have a denominator of 2, my reference angle would be 90. If I have a denominator of 4, my reference angle is going to be 45. If I have a denominator of 6, my reference angle is going to be 30. And if I have this angle of pi, remember this angle of pi is my x-axis, so the x-axis here, radian of 0, is going to be 0. Now I can go through and I can do the same thing here. I know that this is 6, so it's going to be 30, 45, 60, and this angle here of 2 is going to be 90 degrees. So remember pi over 2, this is 2, it's going to be 90 degrees. For the last ones, this is going to be 60, 45, 30, and 0. Now, all I'm doing, remember this is the reference angle, and the reference angle is going to tell us this angle that's closest to the x-axis, okay? Now, here's what we know. If I have this reference angle, these values of the reference angle, from the reference angle, are going to be exactly the same. So if this is 30 degrees, sine of 30 degrees, then that means this is also 1/2, and this is also 1/2. And if I go down here, this is also 1/2. Here's what's different. In fact, let me do a couple more. So if this is 45, square root 2 over 2, and this is 45, it's square root 2 over 2, square root 2 over 2, and down here, square root 2 over 2. Because my denominator in all of these is 4, so my reference angle is 45 degrees. Now, I'm going to draw a little diagram up here. And what we know is this is my positive x, and this is my negative x. So if I'm in the second quadrant, anything that has an x in it, so whether it's tangent or it is my cosine value, it's going to be negative. So in the second quadrant, that's here, in the second quadrant, my tangent value would be negative, So this value of tangent, here, let me just do one whole line here, square root 2 over 2 and 1. So in the second quadrant, since x is negative, that means if I go back, I have sine of y over h, cosine of x over h, and tangent of y over x. So here I have an x and here I have an x. That means cosine has to be negative in those two quadrants. So cosine is negative and tangent is negative. And what you see is I have positive sign values. If I want to look at my third quadrant, so that would be down here in my third quadrant. My third quadrant, I'm going to have negative x, and I'm also going to have negative y. This is my negative y direction. So in this quadrant, I'm going to have a negative y value. I'm going to have a negative x value and a positive tangent. And then in my fourth quadrant over here, I have positive x values and negative y. So here, sine and tangent are both negative because they both have, oh my gosh, I'm so sorry, sine and tangent because they both have y values. So if I look at this, here my sine value is negative, and my cosine value here is also negative. So a little cheat to help you remember this is if you know the first quadrant, then I'm going to show you this if I say ASTC. And this is going to stand for all students take calculus. And this is my sign chart. So in this quadrant, all functions are positive. If all functions are positive, we see that. We have no negative values in the first quadrant. In the second quadrant, because I have an S, S stands for sine, and so only sine is positive. So what do we see here? In the second quadrant, sine is positive, cosine is negative, tangent's negative. Down here, take, this is going to be my tangent, so tangent is positive in the third quadrant. So look what I have. Negative sine, negative cosine, positive tangent. And in my last one, the C here stands for cosine, and cosine is what is positive. And we see this in the fourth quadrant, negative sine, positive cosine, negative tangent. So if you can remember all of this, if you can remember the reference angles, and the reference angles are all based on the denominators, and if you can remember all students take calculus and you know which quadrant it fits into, then you're going to know what's positive and what's negative. Okay, so let's prove this now. Let's look at our last graph, and our last graph is 150. So my last graph of 150 is going to be, it's going to be this guy right here. Okay, so if I go over here and I want to know my angle of 150, so if I'm going by, let me use my colored pen. Here's my initial side, here's my terminal side. This is my angle for 150 degrees. Okay, so reference angle is the angle that's closest to the x-axis. So this is my reference angle. This is my vertical line. So here's my reference angle, here's my right triangle. And what I know is that my reference angle here is going to be 30 degrees. So if this angle is 30 degrees, then my short side is 1. This is the square root of 3. And this value here is 2. Here's the difference. This is the negative x direction. So this is not square root of 3. This is negative square root of 3. So if this is negative square root of 3, when I do my functions here, I have sine of 150 degrees, and that's going to be y over r. So my y value is 1, and my r value is 2. And then I have cosine of 150 degrees. That's x over r. My x value here is negative square root of 3, and my r value is 2. And then tangent of 150 is y over x, and y is 1, and x is negative square root of 3. So when I go fill out my chart right here, my values are going to be 1/2 negative square root of 3 over 2 and negative 1 over the square root of 3. So here are my values for 150. When I go in here and I fill out my chart, here's what I have. So if you remember, this column is sine, and then cosine, and then tangent. So I said down here in quadrant 2, all students take calculus. Quadrant 2, sine is the only thing that's positive. Well, that's what I have. Sine is positive, and the other two are negative. Okay? So I could go in and I could prove every one of our angles, and we could draw these right triangles and use this reference triangle for every one of these to fill out this table. Go ahead and fill out this table, and then in class we'll work on a cheat sheet. I'm going to post another video that is another way to solve this in case you're struggling with the reference triangles.